All right, so this is a continuation of a talk where I was discussing why you might want to use Common Lisp instead of Clojure if you haven't tried it before. And we were also comparing some of the differences between the Lisps so that if you decide to try it, you have an inkling about what might be different. So I thought I would pick up right where we left off on the differences. There aren't too many left, and then we can get into some of the more interesting points. Does that sounds acceptable?
Sure.
All right. So recursion, if you're writing Common Lisp code, well, I won't say most, but many of the implementations will do tail call optimization, and SBCL, which is probably the favorite Lisp for most people, will do tail call recursion optimization, and just something to know about. And unlike Clojure, you will never have to do a recur. You may have to do other things, but sometimes you can have a little more fun with recursion in a Lisp that has the native compilation. When you do a let, basically it's always serial so that multiple declarations, each successive declaration can see a prior declaration. In Common Lisp, it's not the case. If you do a let, each of the declarations can be potentially executed in parallel if the compiler chose to execute or to generate that kind of code. If you want serialized declarations, do a let star. And a foreign notion for Clojure where you don't really have mutable variables except through atoms and other things is if you want to set the value of a variable that you have bound with let, then you would use setq or setf. Let me make this buffer bigger so you can see it. CL user is sort of the default package to play in that inherits the Common Lisp symbols. And then we return X, although setq also returns the value, but anyway. So mutation, you have assignment. This is perhaps significant. In Clojure, if you want to have a special variable, you have to declare it dynamic, and you have to use the binding form in Clojure to bind new values of a special variable. But in Common Lisp, when you do defvar, def parameter, they always create special variables, and anytime you do a binding with let or in parameter bindings or other things, you are binding the global variable, the global special variable. So if I do this, I guess I need to give you a So you see that it has this dynamic global impact so that foo will see the special binding of X. So no need for a special binding form, no need for a dynamic declaration. By default, Common Lisp is very oriented about using special variables. You can, if you want to, make unspecial variables, but actually there's not a top-level declaration mechanism in the language to do that. You would have to define your own. There's plenty out there in other packages, I think. You know how you use letfn and other things to define localized functions in Clojure. In Common Lisp, the version of letfn would be flet, or if you're feeling French, fle. And in Common Lisp, you can also make local macros as well. So there's a macrolet as well. And flet and labels are about the same thing. They both let you declare local functions. But in flet, one function can't see another function. So if you f-let a foo and a bar, they can't see each other. If you use labels, they can see each other. They can each see the other local declaration. There's no sets in Common Lisp. There are some set-oriented APIs, but they all work on Lisps. If you want fancier sets, there are plenty of things out there in Quick Lisp that you can load. There's one called fset, which is an immutable set, so might make a Clojure programmer happy. But you can do union and set difference and other things. It just tends to operate on lists unless you pull in another package. Common Lisp backquotes are a little different. In Clojure, you have backquote and tilde to do the substitutions. In Common Lisp, you have backquote and comma. Of course, they couldn't use comma in Clojure because in Clojure they decided to treat comma as a white space. So just something to look for.
Just a small addendum on that. Clojure's backquotes also qualifies the symbol, like in the current namespace. And that's something that Common Lisp backquotes doesn't do, as far as I'm aware.
I'm not current enough on my Common Lisp macros. I know I was playing with it recently and I was getting qualified symbols. I don't remember if I was doing special quoting.
It could be that the reader does that job, so you don't actually need backquotes to do that for you. Also, there's the fact that gensins are different. In Clojure, the backquotes also has a syntax for implicitly doing a gensin when you want to create a symbol that you know is unique, right? To avoid captures. That's something you have to do manually in Common Lisp.
In Clojure you can go, let X pound and then substitute X pound everywhere for the gensim symbol. Whereas in Lisp, you're going to have to do X gensim, and then you're going to be doing, comma X everywhere you want your generated symbol in your macro expansion. There's lots of packages that play lots of games with gensims and tools to work with gensims and defining batches of gensims for you. So, but on the package qualification, I'm not going to talk about it because I'd be talking through my hat. I still have to work at my Common Lisp macros because I'm just sort of returning to it after 20 years. I know that I've seen my package qualified symbols, but I don't remember the context. One of the things about Common Lisp that is definitely not in Clojure is you can change the character behaviors on when characters are read. And if you want to define, for example, I have a package that defines a pound quote for patterns like Clojure does. Common Lisp doesn't have the notion of a pattern. It has strings, and it can get tiring to make regexps with all those backslashes. So I made my own Common Lisp version of a pattern that behaves like Clojure's Common Lisp pattern by defining the pound macro dispatch character in the read table. And you can actually find that. I have a package out there called Clojure. In Common Lisp, though, there's one global read table, but you can have local read tables. You can have package local read tables so that you can have different packages so that if you're in the package, you're using one read table, but if you're in another package, you're not. So if you have an application and you want all these special read tables for special syntax, you can do that without impacting other code. But the read table is pretty powerful, and it lets you add syntax to Common Lisp for special applications, whether it's rule-based engines or unification logic or whatever you want. In Clojure, nil and paren are different things because paren is a persistent list. In Common Lisp, they're exactly the same. So nil is a symbol. It's also a list. In the old Saturday Night Live joke, it's both a floor wax and a dessert topping. May catch you on occasion if you are used to the Clojure semantics.
An empty list.
This came up in some chat recently. Sorry?
An empty list and new is the same thing. Is that it? I think that.
I'm sorry?
So, the persistent list and CLS, they are the same. So new and empty, like, is this an empty list on common Lisp, right?
Nil is an
That's
empty list, yeah. And an empty list is nil.
Now I'm thinking.
Yeah,
of,
because
like,
in Clojure, new is the equivalent to Java no, and
Yeah.
the empty list is actually a different object. Like if you compare them for equality, you'll get false.
Does it make sense to say that in common Lisp we don't have nil?
No, you definitely have nil. You don't have
Yeah,
null.
Exactly. If your question is like new, you mean null. I don't think you in Common Lisp you have that, but you have new, which is in Common Lisp the empty list apparently.
Okay, yeah.
Yeah, but it's also a symbol, which is weird.
No, I ask because there's this trend on like no on languages is like a four-man solution for a problem. And like not a trend, like the guy who created it actually says that it was his worst mistake. So I didn't know that. It's kind of if that's the case, like it seems like it's a good thing that Common Lisp doesn't have a no. That's what I got from it actually.
Well, it's sort of a more pure Lisp. With Java, you're integrating with the JVM, and null is really important for Java code.
That's definitely
Yeah. The one thing that's actually important to note is that Common Lisp doesn't actually have a separate, like, it doesn't have a Boolean type in the same way that Clojure does. And this might be getting a little bit ahead, right? But in Clojure, false
Well,
and new are two
true.
different things, but in Common Lisp they are actually the same as well.
Yeah, everything in Common Lisp is nil or non-nil. So nil is the only false value. There are libraries that make a type that is Boolean, and they define a canonical true and false for it, and they like that for their application. But in default Common Lisp, it's nil or it's not nil. And if you want something that is like true, it's T, which self-evaluates to T.
This is interesting. Okay. Well,
Okay.
thanks.
So the notion of boundness is something that Common Lisp has. So, if you were to reference an uninitialized memory area in a lot of languages, you would either get random garbage if it was C. You might get some kind of error in some other languages. In Common Lisp, if you reference something that has not been initialized, you will get a unbound exception. So if I reference the symbol X, so the reader creates a symbol X, and we can inspect X, right? There's our thing, and you see on line item 2 here that this symbol X has no value. So if I try to just reference the value of X in the REPL, I get a variable X is unbound. And that happens for classes, and that happens for functions. If I try to invoke X as a function, it's the function for X is also unbound. So you can test for that by bound P for symbol value. It's bound, and F bound P for the function cell of the symbol. So now if I do, and then F bound P again, it's now bound to the function X. So just something to know. That can be really great if you're trying to make your own class notation. You want to, you're trying to do complicated things and you want to make sure that things are initialized and that the correct initialization args are specified. And if you want, you can interact with the methods which handle boundness. You can test for boundness. It's an interesting thing. And this might have been important if you were, like symbolics, making an entire operating system where you wanted to have something happen if you were accessing uninitialized memory. Common Lisp has block comments, so can span as many lines as you like. Whoops, what did I do wrong there? End of file. Okay, it works in the source code. Right. Okay. Here in a I use it. Here's a big comment at the end of my file where I have my to-do notes. It's kind of nice. It's useful for taking lots of documentation. Okay, so why would you use Common Lisp? I would argue that the CL compiler is a huge fit for production code. In Clojurian and the other talk, literally I could put my wife's recipes into a jar file with line install, and nobody's going to get an error trying to execute the class in question until it's loaded into some app and somebody actually tries to call a function in that namespace. And whereas in the Common Lisp compiler, if I have an error in my code and I Control-C it, I'm going to frequently get errors right away, including unreachable code and all kinds of stupid things. I showed a little bit of that in the last talk about how the Common Lisp compiler does inferencing to detect what's going on in your code. It's really powerful, and I love getting those errors. And there's also things like keywords. Clojure has this philosophy, maps all the way down. But if you have a function and it takes a keyword, and that's the only useful keyword, and it's not passing the map down to some other function. Hello, here's my, not sure, okay. All right, so it doesn't make any sense for foo to ever take a Y keyword here, right? And in Clojure, you wouldn't get an error. But in Common Lisp, it's an unknown keyword argument for that function. And to me, this is just a step of, I can do lots of dynamic things in Lisp. I have my dynamic typing, but I really do enjoy having a few basic argument checks. And to me, this sort of thing helps you make more robust code for enterprise software engineering. I enjoy it.
Personally, I agree with you, but for a different reason, actually. The problem is that in Clojure, if you try to take a key from a map that does not have that key, you get nil. Personally, I think that should be an error instead. And that would also solve this problem in Clojure.
The upshot for Common Lisp is that people don't write linters. I mean, I guess some have been written, but there's just not really a need for it to work at linters. And these simple basic tests also help uncover a whole class of errors that you would otherwise have to write unit tests for to know that you'd covered them. So anyway, safety is one reason that I actually think, well, Common Lisp has some dark corners. You can write unsafe code too, but in my day-to-day, I love getting the error right when I'm making it, when that happens, and not a day later. It's mentioned this the last time too, not having the JVM sometimes is a real feature, and having everything compiled up front. You don't have to wait for the just-in-time compiler to do its thing. A lot of Clojure programmers don't even know. If you're trying to benchmark your Clojure code and you're doing like line REPL, the JIT isn't even enabled in that environment. So warming it up for 2 minutes does nothing. In Common Lisp, everything's compiled ahead of time. Don't get me wrong, though, the Java JIT is really powerful. I have a lot of respect for it. The ability to generate executables and other things, the ability to ship your application in a compiled form could be useful to you. But the executables in particular, if you're trying to make games or other things that you want to ship to customers. Shared libraries, as in, something you compiled from C or Go or other languages. Common Lisp has the FFI, the Foreign Function Interface. And there's one called CFFI, which is what everybody pretty much uses. It's portable. It abstracts the FFI details of each vendor's Lisp. And it's just great. You say, load this shared library. You define FFI things that map to external symbols in the library. You can map structs. You can call functions. In fact, it's arguably the case that Common Lisp is a really nice way to do C programming through your C functions. I haven't done it that much, but I wrote this CL roaring thing. I wanted to use the roaring bitmaps library, which is designed to do compression and other things on very large bitmaps. And so there's one out there in C, there's one in Java. I wrote some Common Lisp code to access it. It was my first time using the CFFI and the last. And really, it was just a flawless experience. It was really easy. In fact, my only disappointment with the whole thing was that I was dismayed that the roaring bitmap code did not check out of memory errors and wasn't as robust as I would have preferred. So, but nothing to do with Lisp. And anyway, it's a real nice experience as opposed to Java and JNI and all of that stuff. If you have now the beauty of Java and Clojure is you can access all that Java code. And the beauty of Common Lisp is you can access all that other stuff that's in shared libraries. So it depends what your needs are. Game makers use a lot of this stuff. Structure declaration and prototyping. This to me really goes to the heart of why I like doing Common Lisp. So after 10 years of Clojure, there were some things I tend to write back-end code. So for instance, I wrote a job scheduler. It needed to have these efficient to access high volume number of job records, things that you would use def record or def type for, and that you want to be careful because there's some stuff you'd like to mutate and you want to lock it. And also recently I wrote an octree representation for my game. If I'm writing trees in Clojure, the fact that you have to go and you want to make an update to your tree, you have to go change all the way up to the root of the tree. That's not terribly efficient and it's not terribly convenient to code. So having mutable trees in Common Lisp is just, if I'm writing code and I'm trying to get a startup off the ground or get my game playable or whatever else, it's so much easier to write trees and complex data structures, in my opinion, in Common Lisp. And having CLOS, which we'll get to and with some examples, makes it easier still. And as an example of this, so Clojure, what I would argue is that Clojure is great if you want to do massaging of data. If you want to do extract, transform, load, and you want to use all those partitioning and transducers and things, Clojure is great for that if it has your data structure. But what if you need to define some new behavior? And an example I use is the clojure.data.intmap.intset. This is a really fantastic class in Clojure, the intset and the intmap. It provides ordered semantics for sets of non-negative integers. And it's really efficient. I mean, I've stuck 1 million integers into this thing. It does a great job. And it's also pretty complicated because they make intset conform to all these different APIs. But ultimately, to make this class perform and do all the things that it needs to do, they drop into Java. And so this class. And one of the things about Common Lisp is I never feel compelled to drop down into some other implementation language to implement my data structures in Common Lisp. I might have to tweak it for performance. I might have to do some declarations if it's really a performance sensitive thing. But I can do my bit twiddling and express my algorithms in Common Lisp in Common Lisp. I don't have to do it in some other language, and I really like that. Don't get me wrong, I like Java. Well, maybe I don't. I spent a lot of years doing Java. I've probably written about 250,000 lines of Java. I don't ever want to write another line of Java. So the fact that sometimes you have to do that in Clojure is, well, it's not for me. And we need to show how you would do some interesting data structures in Common Lisp, and we will. The math tower. Anytime I want to do, even if I want to balance my checkbook, I much prefer doing math in the REPL in Common Lisp than in Clojure. And until very recently, they didn't even have an exponentiation operator. So now they have POW finally to do exponentiation. But Common Lisp has had it all, from the start. And it's a little more seamless. You never have to worry about whether you're transitioning into a big num or a ratio. There's complex numbers. Common Lisp just made it super easy to do math right out of the box, all batteries included. And in Java, just, I got to go Java lang math.abs, right? It's just not, it's sort of a cognitive distraction in Java and Clojure.
This is something I miss a lot from Racket, actually. So.
Well, since Common Lisp predated, you think that Clojure did or Common Lisp did?
Actually, Common Lisp predates, Scheme predates Common Lisp, and Common Lisp predates Clojure. Racket is a Scheme derivative, so it's actually newer than both. But yeah, it's historic Lisp stuff. They always had the math
does
tower.
Scheme predate it? Because RSR4 was in the 80s. I remember that while we were doing Common Lisp, so I don't know if it predates it or not. But I'm not a Scheme expert.
Yeah, I think it does. Like, not R4, I don't think, but I'm pretty sure the first Scheme paper actually predates the Common Lisp standards, because there is some influence of Scheme on Common Lisp. So.
Oh yeah, who was it? Jonathan Rees, who was involved with early Scheme. One of the early. Anyway, he would be there hacking with us on Lisp too.
Guy Steele is actually the creator of Scheme, and I'm pretty sure he worked on the Common Lisp standard as well.
Oh yeah, no, he wrote the book Common Lisp: The Language.
Yep.
So character encodings. So with Clojure, you get Java's character implementations, and that's going to be 16-bit representations. And Gookie Boy and I worked at a company where they completely rewrote some Clojure code in another language because those 16-bit characters were prohibitive for that application, and in terms of the amount of memory they use. With Common Lisp, you can generally, it will vary maybe based on which Lisp you're using, but you can specify what character representations you want to use. SBCL actually uses UCS4, I think. So you're using 32-bit characters by default. If you're not careful, you can use a lot of memory on that. Whether you would need to do that depends on whether you want to be able to index into your characters, as opposed to, which is something you might not be able to do with UTF-8. But you can specify that it used different encodings. It's pretty flexible. Figuring it out how, you might have to ask somebody, but because it's not really in the standard. But there's lots of support for multiple character sets in Common Lisp, and that will let you control how much memory you want to use. With all the different Lisps, the dozen or so Common Lisp implementations, all implementing the same standard, you have different Lisps to suit different needs. If you want a Lisp that uses the LLVM, there's a Lisp for that. If you want a Lisp that generates C code, there's a Lisp for that. SBCL generates native machine code, which we showed with a little bit of disassembly in the last talk. I love disassemble. It's fun. Anyway, it's a reason you might be interested in CL, especially if you're trying to do embedded applications or you want that C code. Anyway. I think I think the DSL experience is better in CL, both because you can change the read table and also some of the tools you have as a macro writer to let you express go-tos basically and other things. You have it's more of a you can generate machine, Lisp's idea of machine code for any problem you're trying to solve. And if you're writing complex DSLs that have complex flow control needs, it's all the tools you need are there. Common Lisp will deny you nothing. I'm writing my own DSL at the moment, which I hope to publish soon. It's for a parsing thing that comes from the Rex programming language. See if anybody likes it. This is the toolkit I was thinking. So in Common Lisp, you can generate tag bodies, which are basically blocks, and then you can have go tag for go-tos. Among other things, you can do returns out of the middle of the function and things like that. It can make your life if you're generating code for something, Common Lisp give you tools to make it a lot easier. So I don't know if the Colton compiler uses that stuff, but it seems like it would be attractive, as opposed to having to generate, a complete map reduce that's going to execute over everything, or use the reduced protocol to short circuit it. I don't know. Give me Common Lisp. Games, the shared libraries we talked about, how convenient that is. Candria is a game that lots of people like to reference. It's out there on Steam. It's written in Common Lisp. The ability to package up executables and other things for different host platforms could make your life easier. Maybe not in your DevOps role, but in terms of distributing things to customers or to Steam. Restartable conditions. That's something that Common Lisp has. I'm sure you may have heard about it. I used it recently myself. For example, I have this in my new Rex parse thing. If it expects a string to be parsed, so it's really pointless if it doesn't have a string. So if you pass it something else, I've arranged for it to use a restart. And if I invoke restart 0, and let me make it a little larger here. Unfortunately, not all my Emacs buffers are coming up with this large font size. So it's complaining that it's not a string, and I can supply a new value. I don't have to call it a loss. If you're in the middle of some big program with gnarly stuff, and something didn't go the way you want, I can specify 0. I can enter a new form, ABC, and the parse continues where it was and returns the value ABC. So Common Lisp condition system, continuable conditions. Basically, it's a powerful tool set, and it's not something you can do with exceptions in Java. You might want to use Common Lisp if you're trying to write stuff that isn't going to spend all day in GC. And in Clojure, every single just calling seek will cons up a thing. It allocates memory to do that, and it gets away with it because the JVM has a very good, very capable GC. But if you're trying to eliminate garbage collection, I once had a customer in a garbage collected language. It wasn't a Lisp, and our GC was too slow, and they were using our language for a laser etching application. And as the customer said, if the GC takes too long, it's no longer a laser etch, it's a laser drill. So maybe you want to write non-consing applications. Maybe you don't want your game to pause for a GC. You have a lot of control over that with Common Lisp. For example, you can return values. So common Lisp functions can return more than one value using the values construct. So this one returned two values, 1 and 2. And to deal with multiple values, you have to use multiple value bind or multiple value call or something else. Why would you bother with multiple values instead of allocating a list? Because the common Lisp compiler can allocate and return those values on the stack. It doesn't have to allocate memory. It's just one of a number of tools you have with common Lisp to write less consing applications. One of the things I love is the prototyping freedom, which I mentioned in multiple points. You can just load code all day. You don't have to get out of Lisp. If I'm sitting there in my Lisp and I want to try, I want to try fset, that thing I mentioned that is the Clojure like immutable set implementation. Well, there it is. I don't have to get out. There's no class path. I don't have to deal with it. It's going to bring in the fset. My network is working. It's going to compile it because we're a compiled Lisp, but it's only going to compile it once if it needs to. And then I can muck around with all the wonderful things that are in fset. And I never had to get out of my Lisp or anything else. It's just freedom. It's a degree of freedom. It's not uncommon for me to have a REPL up that's been up for days. All right, CLOS. Any questions so far?
No
Am I going
questions?
too fast, too slow, too boring?
No, it's fine. At some point the screen froze, but like for just 2 seconds, so I think we are fine. Just a matter of curiosity. You mentioned the game Kendra on Steam. I did a little bit of
Yeah.
research, and apparently it uses Trial, the game engine in Common Lisp, which is the same one that we use in our Tetris game that I mentioned to you before.
Yeah.
So if we ever publish that on Steam, it's going to be another game in that list of Trial.
I can't remember. Is that Shin Mara's stuff?
Yes, I think so.
Yeah. Yeah, he's prolific.
One
He,
question.
she, I don't actually know. I don't know the person.
Question?
Anyway,
No, Gustavo has a question.
Yeah. Regarding the restorable conditions, like how this is something that's only related to the REPL. For example, I'm working on trying stuff on REPL and running functions, and all of a sudden, oh, I committed a mistake. I used the wrong wrong parameter for some reason. I only have that thing on REPL time, or is it enabled?
no, they're always there, but how you interact with it will depend on your application. Most Lisp developers testing and running code from the REPL, that's where they will see it. But I imagine if you were using the Common Lisp Interface Manager, that it has, graphical tools for interacting with these sorts of conditions. And you can in Common Lisp, you can create handlers for conditions that specify how to resolve the issue. So you don't have to actually even interact with the user. You could provide in your application a handler that did something else. It read data from a file or it logged a message, and it could decide whether or not it wanted to continue from the restart or whether it wanted to abort the condition, to behave like a try-catch. So you have all kinds of ways of interacting with conditions. You can define new conditions. So not just a REPL thing.
Interesting. Okay. Thanks.
Fun fact, I just did a quick search. Apparently there's a Clojure library that implements a condition system. So I'll have the link here.
Yeah, you can do it in Java. It's just that try-catch isn't going to give it to you. So they would have had to implement a way to signal a condition and to interact with the condition. I've seen that. Do you know anybody who uses it?
Nope, because This is not really a secret, but you have to interop with Java even for some basic stuff. So as soon as you hit that boundary, you're kind of in trouble if you plan to use conditions for everything, right? You have to start to write wrappers, and it gets annoying.
Okay, so let's just start the conversation of CLOS and generic functions. These are two different things. CLOS stands for the Common Lisp Object System. It is one way, it is a way to define classes and things. I showed a taste for it the other day. Oops, that wasn't what I wanted. We were down here at CLOS, sorry. Yeah, this one where I was using, so this is an example of CLOS where I'm defining a class. In these parentheses would be the superclass. This one doesn't have a superclass. It does have a meta class, which adds in all kinds of database capabilities for me. And you can define what your slots are. You can make reader functions and writer functions and read-write functions. You can do inheritance. You can do multiple inheritance. I can't even convey the number of things that are in CLOS. It's a tool that will let you do any kind of object-oriented programming you want. But it might have some cognitive overhead to get started. And it is separate from this notion of generic functions. So generic functions are how you do def method. In Clojure, you have def multi, and generic functions are like def multi, only you don't have to provide the discriminator. It knows how to do a lot of discrimination, and it knows how to do it on multiple arguments. So let's do an example. Here's an example here. Well, no, let me do one in a REPL, I guess. So, foo will now be our generic function, x. Here I'm just defining the generic function. You don't have to do this. I'm going to replace the regular function with a generic function. It's just asking me if I'm sure I want to do that. So I'm replacing the foo function from being a plain vanilla function to being a generic function. And now I can define methods, and I can specialize on x. So if I call foo with some type that has, for which no method can be found, if I call foo of 1, well, I haven't found a method that knows how to handle integers. And it'll say, and quit the debugger. But if I go foo,
Okay, so I think the screen
we're getting everything. So
the screen is complicated.
Yeah, the screen froze a little bit.
Yeah, the screen froze a bit. Okay. So evaluation aborted,
okay,
no applicable. Okay, now we can see stuff.
Okay. Now here I'll do here's where we discriminate on multiple arguments. And this is what Clojure doesn't give you out of the box. You can do it in Clojure by defining your own discriminator, but with Common Lisp and generic functions, it's kind of more batteries included. So this bar function will take 2 arguments. And I'll just say list xy. Very unexciting. So I can also define one that worked on 2 integers. So now we have bar of a list and an integer. We'll just list them. And then we have bar of, 1, 2. We'll add them. And it's just very flexible. It's easy to do. And you can build up quite a lot of methods. And Common Lisp uses generic functions like this, for example, in the printing mechanism. So there's a method in the Common Lisp standard called printObject. There it is. And if I inspect it here, or printObject, it takes an object to print and a stream. And these are all the different methods that have been defined on printObject. And basically, everybody who defines classes whose instances they'd like to print a particular way, I've got a lot of Lisp loaded, I've got a lot of classes loaded. There's a lot of printObject methods. So Common Lisp uses this very heavily. And even in my own little Galaxy class here, I have a printObject, right? So that my Galaxy objects will print out the way that I like. So this is generic functions. You don't just have to specialize on CLOS instances, though. You can specialize on basic Common Lisp things like vectors and hash tables and lists and integers. So that's enough of a intro to just why you might want to use Lisp. I love CLOS for heavy modeling things. Like I like writing models of the universe for discrete event simulations, and I've used CLOS just to ridiculous extents for that, and I love doing it. It's just so much fun. You also have Defstruct in Lisp, and it's kind of a little more like def record in Clojure. So let's see. So Defstruct is just this very simple tool. It can be anything from something like a simple C struct to something more complicated. Ship with a sail and a motor and whatever else. So make ship. And there we go. And it defines print objects. Defstruct is really simple, but really nice. If you don't want to get into the heavy duty CLOS, Defstruct will define all these things for you, like a predicate to determine if it's a ship. Star is the last value returned in the REPL. So in Clojure, that would be star1. Lisp uses star, 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 starts a star. Clojure uses star1, star2, star3. Anyway, Defstruct is quite a nice thing, and you could. Yeah.
I don't get what just happened. Like, you type Defstruct ship sail motor and make ship sail. I don't get it. Sorry, but
yeah, I can try to help you
there?
with that. So you're basically defining a struct with a name and 2 fields. So the fields come after. So you have sail and motor. And then when you define a struct, it does a lot of like runtime dynamic stuff and gives you some functions such as the predicate to verify if it's a ship or not, and a constructor such as make ship. So that's what's happening in there, I think. It's really similar to how Racket does it. So that's why I think it's the same feeling. Really nice, really simple. Did you get it, Gustavo?
Right, so you can also you can it's just a nice way to define things that can be classes. By default, Defstruct will define classes of a form. Depending on the Lisp you use, it may or may not be a CLOS class. In SBCL, these are all CLOS classes. But you can also define Defstructs that are anonymous, so that they will map to any list or any vector. So if you want a Defstruct that you can just use like a template on a vector, very much like a C struct. You can use Defstruct that way too, and it won't define any predicates or any classes. Defstruct has got a lot of nice little things. It's a very, very useful tool if you don't want to get into CLOS and you want to define some objects. And then in terms of CLOS, I have an example for this that I want to show you. maybe not just yet, about how to use CLOS to do things that you would do in Clojure. And one of these notions is mix-ins. And mix-ins add behavior without adding structure to object-oriented programs. And Common Lisp is kind of the language that made mix-ins popular. We'll do that. Okay. Here's an interesting thing in the, maybe this is too detailed. If you want, I can move away from this. You can do threaded program. Well, yeah, this isn't even a thread thing. In Clojure, when you make changes to variable bindings like J, you get these pretty predictable things. But in Common Lisp, here I'm going 3 times. I'm going to push a function onto this list of functions, like I did with Clojure with the swap up here. And the question is, what is this anonymous function going to do? Up here, we did a function that just returned I, right? And I came from this outer scope that we were iterating over. But here we do I3, and I push 3 functions there. And there's a difference here, because in Lisp, in Common Lisp, what you're dealing with is a binding. It's not a scalar variable. And bindings can represent the current value of a variable, and bindings can change. So in this case, we created 3 functions, and in each of the cases, I in that context had a different binding at the time we created the function and pushed it onto the funds list. But when we evaluated them all, they all were pointing to the same binding, and because I was at 3 when we were all done pushing functions, they all have the value of 3 for the binding. So this notion of bindings, it isn't going to hit you usually, but you've definitely left Kansas. This is not Clojure anymore. This is mutability taken to the nth degree.
That is
even
the best
even
way
a
to
traditional
describe it.
language. Yeah, and even in a traditional, in most languages, you have scalar values that are always passed by value. But in Common Lisp, and this can actually vary, the standard is actually a little vague on this. Your mileage may vary. Some things will treat I as a scalar value passed by value, and you would get 0, 1, 2. But it's not actually mandated by the standard. SBCL is treating it as a binding, and just to be aware of. So, and there's a link here to the relevant weasel words.
Is it okay?
And they did that because they were trying to deal with a bunch of Lisp vendors who had different semantics that would have completely wrecked their apps if they changed them. Anyway, I wrote Lisp for years and I never ran into this, right? So it's going to be more where you're, maybe you're doing things and pushing these into futures, and then you might get a surprise. So just have them in the back of your head, those variables are bindings.
Is it okay to think of binding
All right.
the same way I think of pointers?
Yeah.
Or I might.
Sure.
Okay.
Pass by reference. You can think of it as pass by reference.
Okay. Yeah, I was thinking, is it okay, or maybe I'm missing something there?
No, that's entirely a perfectly good way to think about it. It's just that when you look at the code, the way that you use it, you might think it's passed by value. There's no, and depending on the Lisp, it might be treated as passed by value. In most of your code, the code isn't going to be sensitive to it. It will act like it was passed by value in most uses. It's only when you're retaining that binding for an unexpected amount of time and using it that you might be surprised.
Got it. Thanks.
We talked about maps. I don't know if there's anything more to talk about maps. All right. I already pointed to these last week. The Reddit conference on Common Lisp has a reference material section full of tutorials and implementations and everything on the lower right of the page. It's a great resource. And then SBCL is definitely my favorite and free Lisp. It's an incredible thing. A lot of work has gone into it, and it's still being maintained. Kudos to the maintainer. After I was 20 years away, I came back, and like SBCL is out there. It's active. It's good. It's a great Lisp, and the price is right. One of the reasons you might want to use Common Lisp is for scripting. So without the JVM, firing up Lisp is very quick. And because the Lisp executable is very small. There's no jar files. So this is one way you could write a script, or you could generate the executables. And Gookie Boy's been messing with this. This will look familiar. You get into Lisp, you load all the code, you load your application, and then, and this is important, you should do this on the main thread. It's not going to allow other threads. This is meant to be more of a build time tool. You call save Lisp and die, and you can create an executable. And with compression and stuff, they'll be about 38 megs. I hear people complaining about that, but you have to realize that when you build a Lisp system and you save it to an executable, in most Lisp systems that try to shake out unused code, you've still got the entire compiler, debugger, condition system, all these things in your Lisp. It's like an entire development environment. So as far as I'm concerned, if it compresses it down to a 38 meg executable that starts up in microseconds, I'm totally good with that. I'm not worried about the size. And you can also use this, so you've been developing this system, or you have a work and they've got 300,000 lines of Lisp code, and it takes a while to compile and everything else and to load. So you compile and load it, and then you save it as an executable. You can also just save it as an image, so called image-based development. And then whenever you start your development day, you just start Lisp with a different image other than the core image. Normally when you start Lisp, you're using the default SBCL image, but you can use any image you want, including this image. It's got all kinds of things you find convenient to have loaded so that you don't have to load them every time you start Lisp. So not only can you generate executables, but you can generate these custom images that will have your world. And a world is kind of a Lisp term. Like in genera, it's all about worlds. You have lots of Lisp code loaded into worlds. ASDF is how we define systems. It's like your line engine profile.clj or project.clj. So you define what your dependencies are, and ASDF goes quite a bit further though. There's no hard-coded mapping to your file system. You can put your files anywhere you like. ASDF just says to Lisp, this is where you'll find them, and this is what order you should load them in. So ASDF stands for another system definition facility, or maybe it's just keyboard mashing. I'll leave you to decide that. But it doesn't know how to go out and necessarily find all the other systems. Quick Lisp is what most of us use to find systems. It's a bit like Maven, except that the Quick Lisp world isn't really very good about version support. There's other tools for that. But Quick Lisp is what I use for day-to-day development. And you saw me use it here multiple times in this session. I just went out like Quick Lisp fset, right? And Quick Lisp my own projects. And it's how I load everything with Quick Lisp. We talked about multiple values, just two other functions I'll mention, and then let's look at some Lisp code, Clojure code in Lisp. There's a room function in Lisp. It's in the standard, but the output is not defined by the standard. I love room. Room nil, it has a verbose parameter. Yes, so room nil is a minimal thing. We'll tell you about, how space is allocated. And room T lots of stuff about what's allocated where. This can be useful if you're trying to figure out where you're leaking memory or something, or if you're running out of memory and exhausting your heap. So, and different Lisps will have additional arguments for room. Common Lisp also has a time function, so that will tell you how much you allocated and how long it took and so forth. Again, this notion of you can write low consing systems in Lisp, it gives you tools and awareness of that. So
What did room do? I didn't get it.
I wanted to talk about was break.
I think we lost Dave. But I think I can give you.
Oh no.
I can give you what I understood, Gustavo, of what room does. Room is basically telling you the usage of like the environment that you are in. It tells you the usage of the things in there. Heap allocation, stack allocation, memory consumption. It's basically like an embedded val grind in your code, in your environment.
Oh, interesting.
Yeah, so that's something that it's like it goes throughout the philosophy of Common Lisp. Everything you want to know, the bytecode of the disassembler, memory usage, messing up with the reader from the compiler, you have access to all the tooling stuff within itself. It's kind of like a self-hosted stuff.
Can you hear me now?
Yes, now we can hear you. Yes.
Okay, so yeah, I gave an example here of a room before a GC and then the room after a GC, and you can see, which space in the different allocation regions was reclaimed. So dynamic space went from 157 megabytes to 118 megabytes.
Yeah, no,
So
the
these are
screen only
just
shows
tools.
the previous one.
Oh,
So we only see the one with like you did time with print 1. That's the last thing that we saw.
oh, interesting. The screen sharing is not showing my current screen.
Yeah, so I think when we lost your
Uh,
audio, we also lost the screen. And the
Okay,
audio
I'm going to
came back, but the
reshare.
screen is bugged.
Okay, coming. I'm going to reshare. I gotta say, I don't have these troubles with other tools historically. I'm definitely not impressed with Discord here. But could all be a Linux experience. Right. Can you see it now?
Yeah, now we see a room with new and garbage. Then you do JC and then room new again.
Yeah.
Yep,
And
now
so
I
you
see
can
it.
see the memory that was reclaimed. Anyway, this is all tools you can use to see how your application is allocating data and how much GC. You can also make hooks on GC so that you can see how often it's called. You can do things in the hooks. Like you could try to analyze, how memory was being used. So you have tools. And the only other tool I wanted to show you before we go into some more interesting examples is the break function. So you're defining some function and it's not behaving the way you want, and you're at your wit's end, and you want to maybe step through the function. So break will put you into an interactive condition-based environment. Sort of take a beat and examine the state of your program. It's like invoking the debugger from the program. So here we call it foo, and it says break, and so I could knows about the stack trace, and I don't
I have a
have anything
question.
because this is a top level. Yeah.
So let's suppose that before doing the break, you do a let and you make a binding of an x to a value 1. When you go to and you run foo and go to the breakpoint, can you have access to the things defined in the let?
Yes, but you'll want to have your compiler declarations appropriately. So let me let me set the appropriate compiler settings.
Yeah,
Safety
I guess what
3,
you mean is that the
debug 3.
compiler would remove because it's not being used. I guess I understand.
Yeah. Oh, yeah. So that's a thing about Common Lisp that you may find frustrating. I mean, on the one hand, with Clojure, the stack traces are way too long. On the other hand, you always have every stack frame and you know exactly where things broke. With Lisp, being a compiled Lisp, things don't always work the way you hope. Oops. Let x1 break print x. There we go. Def f whatever, and another thing. So we've made sure to tell the compiler to keep as much debug information as possible. And I can't remember how to step through it. Anyway, you can see X there, and
Yep.
I actually don't remember how to step through it here. So sorry, I'm out of practice.
No, but that's
normally
cool
you can
enough.
step through things. You can also call step actually directly as well. So I could say step this whole form. So you can invoke the debugger basically from your code, and now I can stepping over functions or call, step into a call, those usual things. Anyway, there's high-level transforms. It may eliminate function calls entirely. It may inline them. Depends what you're calling, who defined it, what the debug settings were. But if you ever meta dot into SBCL's implementation code on like a sequence function. So like, what is a sequence function? Find. Anyway, we'll meta dot on find. You'll see that there's a function find. Sorry, the font's a little small. I'll make it larger here. And you'll see that there's also these transforms and optimizers, and this is all internal to the SBCL compiler, and it can really change your code. So yeah, you may get into a backtrace on Common Lisp and you may not be able to find anything you recognize. I apologize, that's the way it goes. So Common Lisp is definitely not Java in the backtrace thing. It's just trying to optimize the hell out of your code at compilation time. Reading system source code is an art. I have not mastered it. We're a long way from fun in a lot of those things. And look at these declarations in here on find. You know, every declaration in the standard and a bunch you won't have heard of. You know, truly dynamic extent and dynamic extent, explicit check. No idea what some of these are, right? Dynamic extent, I think, is in the standard. Maybe not. So yeah. Anyway, your source code backtraces may be funny. All right. So let's look at an example, though. I went through an example where I wanted to define Clojure sequence functions. I have a whole Clojure compatibility library. It's a work in progress. But I took a moment to say, how would I do this in Lisp to look just like Clojure, or as much as I could make it? So that's not mine. Here's mine. And here's an example where I'm emulating clear interfaces using CLOS. Let me make the font bigger. Oop. And this is an example right here of a mixin class, right? It's there like a protocol. This is what a protocol looks like in CLOS. And in Clojure's case, it's the iSeq. Let me pull up iSeq here. Here it is. Well, we'll look at Seekable in a minute, I guess. But in Clojure, all the protocols are sprinkled across a whole bunch of Java files. So this is the Clojure source code I have here in my browser. And here's the seekable interface that defines the seek method. And here's where, and then there's the Lisp code where so I don't have to do it in, in Java, every single interface has to be in a different file. So you have to go through all these files to go look at all the interfaces. So I've done that, and I've commented on what their various methods and
Yeah, I think the internet is now unstable.
there's a first and a next and a more.
Dave, are you there?
Okay, can you hear me?
Yeah, no, you just mentioned that
Hello?
in the Java, in the Clojure, you
Here.
have to have many Java files, and in here you basically made all of them in one file.
Yeah.
Sure.
And that so I'm finding all the protocols here of all those files. I've got comments for the methods because I haven't implemented them yet, but there's an awful lot of protocols. Clojure. And then let's go to here. I start on those classes using the generations. I have this thing that exports the symbol. I have to maintain an export list. So by default, when you define functions in Common Lisp packages, they're not exported, they're not public. And all I do is I have a little macro that makes them public. And so here on Seekable, barring if I don't know what the thing is, because T is the top of the type system, all types converge to T in Common Lisp. If I don't know what it is, I'll say Seekable is nil. I know that if it's null, if it's nil or an empty list, right, that Seekable is going to return T because we treat lists as Seekable. And other methods for Seekable will be implemented elsewhere. So this is just the basics. And so here I'm defining but these are just the rudiments. Now we get into like list. Here's my persistent list in Common Lisp to behave just like Clojure's persistent list. So they have an empty list in Java that implements all these interfaces. Let me make the font bigger. And I have an empty list in CLOS that implements all these interfaces, which are mix-in classes in CLOS. And here I do more specializations of some of the generic functions I defined in the other module, hash codes, toString, first, next, more cons, all that stuff. And like Clojure doesn't actually have a cons in the way that Lisp does. A Lisp cons is nothing like a Clojure cons. And in Clojure, I'm making a persistent list, and this is the implementation. And when you call, so where's my persistent list? Here's my persistent list class. It's got these slots tracking first, rest, and count. They're immutable in terms of when you use them and create them. So now I'm using my persistent list, and it's returning persistent, my CLOS version of a persistent list. So this was just me messing around, but it was instructive to look at how Clojure really implements all these things and to go and implement them in CLOS. And the nice thing is I was able to do it in 2 nice modular files, right? It was short and to the point. Whereas in Clojure, it's a lot of Java and a bit of Clojure sprinkled around, and mostly in core. But So the whole file is what? This whole persistent list implementation is 101 lines. Not including all the mix-in classes. But anyway, I'm not sure how useful this is to you. I'm hoping it just sort of you can do all this stuff in Common Lisp. If you want to make closure sequence abstractions, you can absolutely do it. Questions?
About the SQL thing, sequences, I think you did great. The fact that you can do this in 100 lines, I think it's an achievement. And in one single file, aside from the mix-ins, that's great. You don't have to interrupt with any other language, such as in the case with in the closure case, because you have to do closure in Java there. Here is just a single thing. Yeah, pretty nice exemplification of the abstractions.
Let's see, what else did I have in the tech talk? I think that's the end of my tech talk bullets. Was there anything else I want to show you? So back to the why would I use CL? I like that I can define anything without dropping into another language. I like that I can load and define and redefine all day long without having to restart Lineagen or other things and wait for jar files to load. I still love Clojure. I expect my next job will be in Clojure, but it might be in Common Lisp because I'm really enjoying going back to it. There are some dark corners though, like that binding. If you create futures and you spin them up in a loop from I from 0 to 10, and you don't get the results, now you know. Look at the bindings. It's not that there's a bug in the threading. It's just that Lisp treats the notion of bindings differently than Clojure does.
I do have a question
And
now.
then there's also yeah.
So aside from games, because after my experience with the trial game engine of Candria, I don't know exactly if I would recommend a newcomer trying to try it out Common Lisp making a game with trial, because there are many corner and quirky things about that thing. So what would be your recommendation, Dave, of your first Common Lisp project for a newcomer?
It depends on what your interests are. So, like, I have a colleague that Gookie Boy and I both have. His first thing was to go and implement a game, and he tried a number of different things, and he wrote some side-scrolling games in Common Lisp. I don't remember what technologies he used. I'm not a GUI guy, so that's not something I'm going to do. I have written multiplayer simulation games that took orders in different ways, and I'm actually working on one now that works through the browser. But I'm really a back-end guy, so for me, it's all about how do you model the universe, and what does your discrete event simulation look like, right? How do events propagate between objects and things like that? It's very enjoyable work, and it's CLOS that makes it so enjoyable for me. CLOS and generic functions and all that stuff, and so in terms of how to get started, it's just got to be a problem that you want to solve. So for me, it was on my very first game. CLOS didn't actually even exist then. There was a flavors implementation which was pre-CLOS, but I just used Defstruct. I didn't even use CLOS at all, and I was able to model my universe using Defstruct and get a game out. So I'm not sure how to suggest there. You can go whatever you want to do.
Okay, so anything is a good thing. Okay, that works.
If you're really a Clojure fan and you want to do some Lisp, but you miss some of your favorite Clojure things, I've really been enjoying implementing pieces of Clojure in Common Lisp, and I alluded to some of them the other day. So like, I made the ClojCon package, and I'll just show you real quick here. Where do I have it? Oh, I took it down. Anyway, it does future all the asynchronous stuff in the Clojure core library. So maybe we'll do a little sleep, right? That doesn't look right. Does that look right? I'm missing something. No matching parentheses. Future, sleep 4, format T. Oh, I'm missing quotes. Oops. There we go. So there's my future running, right? And I've got promises and deref and all that stuff. And I really love using these tools in Clojure, especially in testing, integration tests where I'm trying to test asynchronous code. And so this was not too painful to generate in Common Lisp. Similarly, you know, I have my so if I little utility functions like dir. Clojure has dir, dir of a package name. I made my own Clojure dir in Lisp. So it's just fun to do, and you learn a lot of things about the dark corners. So it's a way to get started if you know another Lisp. Implement your favorite Lisp things in Common Lisp,
That's actually a good call because
or
many,
not.
many languages they have a hard time being popular because they lack tooling. Just make the tooling. Make the libraries,
I've
I mean.
learned a lot. I've been away from Lisp so long, and I really learned a lot about some dark corners. Like I made a version of Clojure's def. And for that, I had to learn a couple of new Common Lisp things that are in the standard that I never knew about. So it was informative.
Definitely a good suggestion. So I don't have any more questions. So do you have any more questions? Marinho, chat, Gustavo, do you have more questions?
I'm good. I'm good. I really like this presentation. I think it's very in-depth. Well, in-depth if you're like not into Lisps and you're new to Lisp. Since we all know Clojure and this is common Lisp for people who know Clojure, yeah, this is kind of in-depth if you think about it.
Definitely that, like a lot of very specific common Lisp stuff that you don't really know if you're not into it. It's pretty cool.
Yeah.
Um, I,
So
I have one thing that I wanted to ask actually. So it's possible to uh like deploy applications, not deploy, that's not what I want, but create the executable for a common Lisp application by using save Lisp and die. But you like, is this always the end case of it? Like that's the way you actually do it? I know you can use S stuff to declare more stuff, but does it use save Lisp and die in the end of the road?
And what I didn't hear, what does what use save Lisp and die?
Yeah, if I want to create an executable,
Mm-hmm.
I think his
so
question is
Then yeah, you'd use
go.
uh, yes, if you want to use an executable, then that's your only option is to use save Lisp and die, and that's probably going to be in your your production build steps, right? But then the other way
okay.
is people do it to save their worlds, so they get a world, it's at a good state. This is your development world. It just takes if it takes you 20 minutes to load your world because you've got so much code and you're using so many third-party libraries, you won't want to do that every day. So you might load it up once, save Lisp and die, and then make that your base image. And you can specify which image SBCL will use, including an Emacs, so that all the stuff will be predefined and you can increment from there.
Interesting. So the utility that you use to create an executable is also right in the language, like it's contained into it. And in the end, even as stuff or whatever you're using, you're actually running save Lisp and die at some point.
Yeah, maybe. I almost never use it, but I'm not shipping any executables to anybody.
Yeah, I think
So I don't have.
Really? Okay.
I think this is a good example of like if you want to ship your game to Steam, I think you're gonna have to bundle it with the entire environment as David demonstrated. So you're basically like you're shipping the game and the environment together in a single thing, in a single package. And then what Steam will be end up doing is calling SBCL, calling the main function of your game. That's how I think it works. When we were making our Tetris game, I think we discussed a little bit about that, and the conclusion was exactly what Dave said. You ship the environment with it.
There's a Candria article out there where I think he wrote up at length what his build steps were. I could be confusing it with some other Lisp app, but there are people who ship, Lisp deliveries on Mac and Linux and Windows, and have tools to generate all of those deployment bill of materials. In the case I'm thinking of, they did it all from Linux, I think, even for cross-platform use. But there are definitely write-ups out there of how you might do this if you're interested. I couldn't point you at it offhand, though.
Yeah, okay, but that was a good question. So if you don't have any more questions, I'm gonna end the recording. Do we have any more questions?
All right, nice to see you all. I'm glad we got through it. I know the difference thing was kind of might have been a grind. I probably should have cut it out. I don't know, but I wanted to make sure
Not
you
at
were
all.
armed with
Not at
things
all.
to be aware of if you were going to go and write Common Lisp and you're a Clojure programmer. So,
Yeah, exactly. I think we did great on
I
that.
enjoyed it. I enjoyed it a lot.
That's true, yeah.
Yeah, so it was a pleasure, Dave. I'm gonna finish the recording now.